We're given the graph of g of x. We want to sketch the graph of its inverse on the same grid, find out if it's a function, and state the domain and range of both. So we have a point. We have the point negative 4, 4. If you switch x and y, where's that point going to go? 4, negative 4. Take your second point. Negative 1, negative 1. If you switch those, you're going to get negative 1, negative 1. Our next point, 1 comma 3. We're going to get 3 comma 1. And finally, our last point, 3 comma 2. That's going to give us 2 comma 3. Now, even though we've drawn and have all 4 of those points, sometimes you're going to get confused. How am I going to connect the dots? And you might connect them in the wrong order. So this is where knowing that the inverse is a reflection over this diagonal line is going to be important. Because then you can turn your page diagonally to flip it over easily. Can you see that this flipped over would become that, and this part flipped over would become that? Wow, that's not a very straight line. Try that again. This, even though it's not a point that was originally labeled, where your graph crosses that line y equals x, your inverse needs to cross as well, because that's where your y and x are the same. Can you see that this part would reflect to there, and this part would reflect to there? So having that diagonal line to reflect it over helps us as well, even though we had labeled all the points. Part B. Is the inverse a function? Well, now we're going to have to go back and think, how did we in the past tell if something was a function or not? Do you remember? Something like that. There was a special test that was easy to use. It was that kind of test. The vertical line test. A review of the vertical line test. If you have a vertical line and you're going from left to right across your graph, if it only touches one point at a time, watch the red graph. Can you see as I go across, it's only touching the red graph at one point? The red graph is a function. But on the blue graph, as I go across, if it ever touches more than one point, like there, or here it's touching 3, if it ever touches more than one point, then it's not a function. So we can say, okay, sketch the inverse. The inverse is not a function it doesn't pass the vertical line test, which means, and this is sort of what you were saying, there is an x value that has more than one y value. Now, in the English language, we use the word function to also mean something works. You know, this functions, this doesn't function. This is working, this doesn't work, right? When you use your calculator, you want it to work, right? 5 times 5, you push equals. Every single time on everybody's calculator, it should say 25. That calculator is functioning. If you had a calculator that started to tell you different answers, 5 times 5, 19. You're like, what? Check it again. 5 times 5, 25. Okay, that was weird. Look, I did 5 times 5, 37. What? You would say that that's not working right. It's broken. It's not functioning. So in math, we want something to function to only give us one value all the time. You put something in, same thing comes out. That's what makes it function. In this case, right, you plug in, if I go to 0, oh, 2 different values came out. It's not functioning. And so whenever an x value has more than one y value, we say that it's not a function. State the domain of the original function and its inverse. So our red original function's domain and range, well, I'm going to use interval notation this time. We have a smallest x value at -4 and a largest x value at 3. So it goes from -4 to 3. And the range, we have a smallest y value at -1 and a largest y value at +4. So our range goes from -1 to 4. Then on our inverse graph, our domain now has a smallest x value of -1 and a largest x value of +4. Our range, we have a smallest y value of -4 and a largest y value of 3. Compare the domain and range of the red one to the domain and range of the blue one. What do you notice? They've just been flipped, which makes sense because with our inverse, the only thing that's happening is you're switching x and y. So it makes sense if you switch x and y that your domain switches to become your range, and your range switches to become your domain. Okay, try questions 4 and 9.